Hello everyone and welcome back. I hope you are enjoying the second day of sessions and I really appreciate that you are stopping by to listen to this one. In this day, we are going to be talking about Skupper and how this tool builds on a virtual application network and help us extend Kubernetes deployments so we can abstract the cloud deployment and the cloud definition on top of the networking so we can deploy true hybrid cloud applications. My name is Hugo Guerrero and I welcome you to this session. A little bit more about me. I'm a Mexican currently based in Massachusetts in the United States, and I'm part of the Red Hat team that is in charge of APIs and event-driven architecture. I'm an open source advocate, and here's my Twitter handler if you want to join the conversation offline, or do you want to provide some feedback to this session, or just to engage in any type of follow-up. Today's agenda, it's pretty straightforward. It's very simple. We'll be talking about how great is Kubernetes and what happens when you deploy your application on one single cluster, and then what happens when you move to a multi-cluster type of deployment or a multi-cloud requirement. Then we will be talking about what is a virtual application network and the requirements to run everything as local and having virtualized applications. Finally, we will be talking about Skupper, and we will be doing an overview and a demo that I hope you like it. It's involving multiple cloud and an application that it's distributed around those clouds. So stay with me, and I hope you enjoy this session. Cool. So when we talk about Kubernetes, most of the times when I achieve something, I feel like this, right? I'm riding with this nice fellow that looks so cute, and this is how I feel when I deploy my single Kubernetes application. When I discover that there is services and that the platform can provide me with most of the solutions that I used to have to deal within my code in the past. So Kubernetes has this capability of abstract all the underlying infrastructure and then just provide resources through the API server and services and pods and deployments, as well as storage through the persistent volumes and persistent volume claims. So it is super awesome as a developer being able to push all those kind of decisions, all those type of configurations to the platform, to the infrastructure, and then just focus on our application. So instead of using histories or adding any other type of library into my code and thinking about how do I start to deal with circuit breakers or how to deal with retries, I can just rely on the benefits of having my service mesh deployed in my Kubernetes cluster, and knowing that if my pod fails, it will be rescheduled by the scheduler, and the deployment will be there for my application to be accessible. The ingress service, it's going to be there, and it will be balancing to my different pods if I do have many. So it's super great. We're having a fun day, and we hope that this continues for the rest of the production deployment. However, suddenly when we need to get into production, and we suddenly realize that most of the times we don't be just dealing with one single Kubernetes cluster. If you're in a regulated industry, or if you actually need to deal with a distributed application that needs to reside in different continents or even different data centers, and you're even using a managed service, it gets a little bit more complicated. So when we do actually need to face those problems, it becomes like this, right? When we're dealing with multi-cluster Kubernetes, that little fellow, that cutie fellow that we were hanging around with, suddenly transforms. So it's like when Kubernetes gets wet and it multiplies, and then after it multiplies, you're just forget that you have to avoid giving them any snack after midnight, and it becomes really awful. Why? Because most of the times Kubernetes is not ready for being a multi-cluster. It's decentralized. Its centralized control plane allows you to control and configure one single cluster, but extending or stretching things like ATCD through multiple regions with problems with the latency, it really gets problematic. So most of the times you will be get caged into just one single cluster, and this has been happening for a while. It's not a single problem from Kubernetes. Kubernetes just make it very visible because of the same limitations of its nature. But when we used to have SaaS components and we had to connect from our own data centers only to things like Salesforce, for example, we still had the exact same problems, right? And most of the times we used to create new solutions and new components so we are able to deal with this kind of problems. One of the things that we had to move into when getting away from the monolithic application with distributed applications was to start thinking about services and thinking about APIs. And when running on APIs on the single network or in a single cluster, well, we can rely on the Kubernetes DNS, for example, for resolution, and rely on the services. However, when we suddenly need to go outside our domain or outside our cluster, even with APIs, we need to do different things and we need to tackle it differently. This is where things like, for example, API management and the API gateway had to be created, had to be implemented to be able to control the access and to have a way to expose the communication between trusted and untrusted domains. When we are targeting public clouds, they are having public endpoints that we are able to connect to, and then we can consume those resources. However, if we are talking about our own data center, our own private cloud, most of the time we just cannot open a lot of ports and just expose APIs in a single by every one and every single service, because that becomes a nightmare. So things like these API gateways and API management needs to be implemented as the way to access in a controlled way to services living on our own data center or on the private network. And then you need to start dealing not only with perimeter type of security through web application firewalls, but you also need to think about the business and who has access to which one of the services, and you need to add more control on top of that. And that's actually a solution to a problem that this type of asymmetric type of security that you have with the different clouds, right? So it's not just between Kubernetes cluster. It's also a problem with the actual multi-cloud type of connectivity. Because most of the times, what we as developers want is just to have everything available in our own domain, in our own space. But there's no place like home. We want to run everything as any of other service required is local. Why? Because we actually don't want to think about how do I need to connect to X service, right? N service. Because most of the time we just want to just access and see the database that it's located there, or the API service, or even the CRM or the ERP, like SAP, to be able to connect and consume that locally. However, it's not possible. We used to have that in the past when we had our own data centers, but now that all the services are being distributed, that we need to suddenly do an overflow of the load, we need to start thinking about how to solve the problem, how to be able to get to those services, to be able to consume those applications and expose our own services to the rest of the ecosystem and the rest of our applications in the system. If you want to try to solve this using just networking at the Kubernetes layer, well, there's a couple of solutions and a couple of projects that are working towards trying to get a solution for bridging or binding all these clusters together. However, it's limited to just one single type of implementation, and it's very focused on the networking only. but the networking that it's building, or that it's in which it is built, it has its limitation. It was not designed for the actual type of multi-cloud and the omni-cloud that we are targeting to. So we're just patching around, trying to make it work, adding just more type of configuration and layering on a solution that it's very complex by itself, and it's limited on its reach. So we need to do and think in a different way, so we can isolate the different type of problems, so we can solve them in a different way, and we can actually focus on the solutions that can help us to deal with each one of those domains. So this is why we are thinking and Discover project around virtual application network. Virtual application network, if you recall this this movie, allows this type of ideas of having a virtual instance of a persona in the case of the movie, that it's available and it looks like it's with us, right? Like it's right to our left or right over to our side, and we can interact with that image or what that virtualized instance, and it is present not only in our meeting room, but it's also available in the rest of the meeting room. So think about any Zoom meeting or any Hangouts meeting where we are able to see and interact with all the rest of the people that it's in the same screen, and every one of the attendees to that meeting has the exact same visibility of what is happening. So we are in all the different locations, but we are not actually teleporting, or you are not cloning ourselves to be in those places. We're actually just projecting a virtual version of ourselves in that meeting, in that software, right? So that's the idea behind virtual application network, being able to provide the service as it is there. You can interact with that, and it will certainly answer you back, but it's not going to be running there. It's not going to be there. It's going to be in another place with a different perhaps setup, and mostly you don't need to think about how to get to there, or how is it what is the place where this person is. You just need to know that you need to connect to the Zoom application, and it will be able to show the this image of the person. In the case of the movie, you can see that the person is there, and they can see the other persons that they're virtualizing, and you can interact. This is the concept then of a virtual application network, where we have this abstraction layer between the network and the application services. So it's this buffer that allows us to decouple the implementation details of the communication at the application layer and the actual topology of the network. So in this case, we can, by getting this decoupling, we can then focus and solve the requirements and the problems for each one of those layers. And the most important things that this abstraction layer brings to developers and the application development is that your applications don't need to be modified. We have seen other efforts that at the application layer, at layer 7, that require you to add libraries to your application, that you need to be aware of the topology, think about the service that you need to register, and so on. So the idea of the application, or the virtual application network on top of Kubernetes, is being able to handle the application as it is. If it is using HTTP or REST APIs, it needs to be transparent and seamlessly able to reach that service across the network. If it is gRPC, if it's a messaging protocol like Kafka, for example, or if it's just a TCP connection, like for example a database, it's one of the use cases where you can have a virtual application network that exposes a database in your namespace as if it is running in that same place, but it's actually deployed on another location, another cloud, another type of technology. So it is actually a very good fit for Kubernetes and Docker, where we can have this abstraction and the concept of services to be able also to then just offer to the application an endpoint that it can easily consume, and then push the rest of the communication logic into the infrastructure. But in this case, the application topology is totally independent from the network topology. That means that if you need to manage your network, handle your IP segments, deal with your connectivity and your VPNs at the networking level, at the L3 level, there's no need to force your application to be able to feed that topology. Your application can be distributed across all those networking and all those kind of implementations without even notice that there's this per type of infrastructure at the networking where you are running. So that's why Skupper was created, right? Skupper, as the as it is described in their site that you can access actually here at the Skupper.io, is Skupper. It's a layer 7 service interconnect. It enables secure communications across Kubernetes cluster with no VPNs or no special firewall rules. They got me there in the first moment they said no VPNs, because it's super complex when you're running on a restricted service to be able to access sometimes exposure. So you need to go to the CSO, CSIO, and need to go over layers of configurations to be able to get one service up. So it's super interesting on how we can get a secure connection that is self-service, that allows you to run your application anywhere and connect at the same time from everywhere. The Skupper is this project that targets to get this working. If you want to follow them on Twitter, that's the Twitter handler, Skupper.io Twitter, and that's the web page. So Skupper, it's then an implementation for a virtual application network. Then let's see how it works, right? Let's see how this application network works. And actually the slogan, it's run anywhere and connect from everywhere. So let's see how it works. Well, now it's time to see a virtual application network in action. In this case, I have an environment including 3 clouds. One, it's a private cloud that is running on my laptop, so it won't have any external exposure, so nobody can connect actually to my local environment. Then we have an K8s cluster running on Azure. And finally, we have an OpenShift cluster running on AWS. So in this case, we will start with the local machine and creating a namespace called local. So we create namespace local. First, that there's no pods running. And then initialize this namespace using the Skupper CLI in a cluster local mode. Now it's time to go with Azure. Let's create a namespace here called Azure. And then let's initialize it using the console with unsecure authentication. So we can provide a load balancer IP to access from external. Now with OpenShift, we can create an AWS namespace and then initialize it using the Skupper CLI. In this case, it's running locally, so we need to update this to run from the local folder. So it's /Skupper. And now it initialized to. Okay. Now we can check the pods that are being deployed. And now we can see that there's a Skupper router and a Skupper service controller in my namespace. Let's then check the status. So currently Skupper is in local edge mode here, and it's not connected yet to any other system. So let's check the pods running on Azure. Again, we have the router, And then let's check the status, and it is available without connections. Time to check AWS with OpenShift. We can check that there's the router pods running, and then we can check the status. It's available and ready to connect. Now for the connection, we need to get the service information, so we can view that the controller has an external IP, so we can select this IP running on port 80 or 80. So we can go to our browser and then use that IP address in the port 8080 to check the web console for Skupper. So this is the web console currently listing the services and some more information about our configuration. Let's now create the connection token for Azure. So this will create a secret with the information required to be able to connect to Skupper. It has the endpoint name and the secret. So let's download this file called Azure secret, and it's a YAML file. So we can download that from the K8s cluster. We can allow to download on our local system. So that's now in my local drive. So we can then take a look at the YAML file. Let's do a BI, Azure secret, and we can see there's a YAML version Kubernetes secret with information on how to get the connection to this cluster. So let's use this YAML file locally and then edit a file here in my local system. In this case, we will be doing again a BI with the Azure secret YAML file. We just paste this the content of the previous file with just a download. Let's insert all the content. Let's then save this file, and then we can do the connection. So it's gonna be Skupper connect, and then we just provide the YAML file with all the information. In this case, we're gonna name the connection name local to Azure, so we can identify this easily. And then hit enter, and then the configuration it's ready to and connected. So we can check the status with Skupper CLI, and then we can see that it's connected to one other site, and there's no services exposed yet. Let's do the exact same thing in AWS in the OpenShift cluster. So in this case, we will be creating the Azure secret. We're gonna be pasting the exact same content. The information is the same. We save the file, and then we can run Skupper connect with the name AWS to Azure as the connection name. Now we can check the Skupper status for the OpenShift cluster. And then here we can see that now this cluster is connected to two other sites, and one of those sites it's indirectly connected through the Azure side. So let's see on the console how we can now take a look at these three clouds, these three Kubernetes clusters that are running on my environment. So we can see the AWS cluster and the local and the AWS connected to Azure, and they are all bridged together. So let's go back to the local environment and create a deployment. It's going to be a backend service that is going to be just replying to hello world. This is created in two sites. We're going to create that in the local and also in the OpenShift site. So we also create a deployment here, and then we have both pods available for high availability. In the local, we have the backend pod, and also in the OpenShift cluster, we have the hello world backend pod running. Now it's time to deploy the front end. See, there's no pods running and on Azure. Let's create the front end deployment. This is going to be the only pod running on the Azure cloud. So there's only the Hello World frontend. There's no other pods running here besides the router. So it's time to check the services. Again, there's only the Skupper services available. And now let's start to expose using a Skupper the deployment of the backend as part of the Skupper services. And the OpenShift service 2 expose the deployment. And now this will create the services around all the clouds to be available. So let's see in the local, the service it's already created. So it's Hello World backend, this service cluster. Also, again, on the OpenShift, there's a Hello World backend service created. And now this same service should be available. If we can see the list of exposed services, we know that there's the Hello World backend service and the application listening. On the Azure cloud, we can take a look now on the services here, and we can see that there's the Hello World backend service being created also in the Azure cloud. So we have the service all the three clouds, but there's no pod running here. It's just the front end. So we have the service, it's virtualized service. It's time to expose the deployment of the Hello World front end. The port 8080, and then the type will be load balancer. Okay, this creates the service for the deployment. So if we see now the services, we see that there's the backend service and the front end service. Front end service has a cluster, an external IP address, so we can use that to access the front end service. That is just a simple GET call. We can go to our browser. We type in the external IP address, port 8080, and then we can see that it loads the application. Let's do it a little bit bigger so we can see that's just a single message showing the name of the pod that is currently answering this request. So if we do a refresh, we can see that there's also a counter and information about the pod name. So let's see which one it's answering. So in the local cluster, we can get the pods. We can see that the pod name corresponds to the pod name being shown by the application. So in this case, the front-end application, it's been tunneled through Skupper to the local cluster in my laptop running, and then being able to access that service. If we go to the console, we can see that the destination of the site, it's my local cluster. So it's the cluster that it's currently answering those requests and how is it flowing. To check the high availability, let's scale the deployment, Hello World backend, and then put the replicas on 0. So we can simulate a shortage in the system. So this will scale down the service. We can try calling the application again. It will respond until the pod it's terminated. In the moment that the pod is terminated, then the application will automatically reroute from the local cluster where it's not available to the OpenShift cluster. Now we can see there's a new pod answering back, and we saw the update in the screen. So let's just verify that it's the exact pod that is running. So we get pods, and yeah, the name is exactly the same as the pod that it's currently running in the OpenShift cluster. So from Azure, it's now calling the AWS service cluster. And let's get back the local service, and let's do a failback. Let's restart and check that it's still answering on the OpenShift cluster. and we can see it's still that one answering back. And then let's scale back the service running on top of OpenShift. So let's scale deployment hello world backend. Replicas equals 0. And now that there's no pod running on OpenShift, we should be falling back again to the local cluster running on my laptop. And here it is. Now the cluster that is answering black, it's my own laptop. Amazing, right? Let's get back to the slides. So you've seen now how you can do this kind of networking with different clouds and deploying the application just as the Kubernetes level. It's no need to create all these crazy things around. And this is because we are relying a lot on the Kubernetes service. In this case, you have on your cluster a service that its name is service A, and then Kubernetes takes the link between that service that it's actually handling the request and the pod or the actual instance of your application that it's going to be answering the call to that service, right? So the pod has a cluster IP, and then the service resolves which pod is going to be serving that specific request. You can add and throw into the Kubernetes cluster some things like service mesh, so you can get all the benefits of shadow traffic and policy rules and security, mutual TLS, and all those kind of things. But the interesting part, as you can see, is when you can have the exact same concept of the service, but extended to multiple clusters. So in the case of the example or the demo that you just saw, in our case, we have a service being created in the namespace where my front-end application it's running, but there's no implementation of the backend service. Instead of that, we are using the virtual application network routers to be used as proxies to tunnel the communication to the actual endpoint that is listening at that exact same service. So when we are exposing the service of the backend, in this case in cluster 2, we have the pods running, then we are having the service being exposed. The virtual application network takes that service that we want to expose and then projects a virtualized version of that service to all the different clouds that are connected to that exact same virtual application network, and creates all these services remotely that can be used as if they were local to our services. So in this case, for example, the application that is the front end just needs to call the service hello world backend, and it will get the answer back from one of the pods running in the infrastructure. We don't need to know which one, and we don't know where. We don't need to add anything else to our application to be able to handle that. It's just calling the backend service, and it will be served as part of the backend service. And what can we then take further? Well, is that when we have a virtual application network that is connected not just two clusters, but it's connecting more than one cluster, and that cluster can be on the same network, it can be just a different Kubernetes cluster, it can also be just a different namespace in the exact same Kubernetes cluster, but allows us to create this networking at the application level where we can connect everywhere. And because the protocol transport that we are using on the virtual application network allows us to do things similar to what we have in the networking layer, we can do things like omnicast, anycast, or multicast, where we can just then take a connection or a call to the service and then be able to either load balance between different services, or even be able to send the request, if we are talking about like messaging or TCP, to 2 or more different type of destinations. The request will be routed to all the different service implementations that exist in the network that has the same address or have the same service in the Kubernetes lingua, right? And that's why when we were doing the load balancing in demo, we were able to easily switch because we had both instances of the backend service running in 2 different clouds, and the router of the virtual application network is able to look for the shortest path or the fastest way or the cheapest way to get into a service that it's available. Also, this kind of virtual application network allows us to have a high availability, not by adding more routers, but just by adding more paths. If you remember in the demo, we had just one single public endpoint in the Azure cloud, and we had the private cloud and the AWS cloud being able to connect to that Azure service, and the applications were able to see all the different services available across the whole network. In this case, we can add more paths and more points of contact, and then we can have more paths available for the connections to be established. So if we add another network that is another node of the network that is mirroring the Azure service, and we connect AWS and the local network to those nodes, then if by any chance one of the Azure networks fails, we can just reroute all the connections and all the services to the other path or to the other link, and we can still get access to our connection and access between our local network and the AWS network running on OpenShift. So it has a lot of potential. This implementation, it's very interesting. Going on more on the details of Skupper, and this is what I really want you to take home today after this session. Skupper is a project that it's already there. It's out. It's 100% open source. It's based on Apache 2.0 license. So it's a very nice implementation of a virtual application network. It's very useful, as we mentioned, if we're talking about Kubernetes, where we have all these concepts of service, but it goes beyond just using Kubernetes. So if you're able to run the container image in a Docker daemon, like for example, running on top of Linux, you can even expose local services running on a virtual machine through this container image running on Docker and to the network, and then create these virtual services on your Kubernetes cluster that access non-Kubernetes deployments. So it's also pretty interesting. The project is called Skupper Docker. This router, it's based, this virtual application network implementation with Skupper is using the QP dispatch router, that it's a component from the Apache project, Qpid, that allows you to do this network routing. It's using as transport protocol the MQP protocol, but it's not just for machines. It's for connection. So it's actually working as a router. It automatically computes the topology. If there's a change in the network, it automatically propagates all the changes. So as we mentioned, if suddenly one of the nodes on the network fails, it automatically will reroute all the traffic to the rest of the nodes. So it keeps the connection established and the network working. Because of the implementation of the router, it's pretty lightweight and fast. So it really has a very small footprint and does not need to use this concept of sidecars for doing the connectivity between centers. So you can use sidecars if you still want to use the service mesh in each one of your clusters, but it's not a requirement. It won't be adding overhead to each one of your deployments. It will just benefit of whatever you're running on top of your cluster, and it will just bridge between the different clouds. So I invite you to go to Skupper.io, follow Skupper.io at Twitter, and if you like it, we are ready to get engaged, and we also like to hear and get any feedback from you all. I hope you enjoyed the session. I really appreciate the time that you spent with us, and Thank you very much. We really really appreciate, and see you later. Thank you.